Welcome to Ready to Derive. In this video, we're going to learn to find the domain and range from a graph of a function. So just to recap, if we had a function that looks like this, and if you recall, the domain represents or is the set of all x coordinates represented on the function. So if you look at the x coordinates there, you could list them out as this. And the range, similarly, is the set of all y coordinates that appear on the graph. So if I list all the y values in this function, they would be this. So that's pretty straightforward. But what if we had a graph like this? We wouldn't want to list out all the x coordinates and all the y coordinates, so there must be a better way, and that's what we're going to learn about in this video. So without further ado, let's begin. So let me start by introducing you to a useful technique for finding the domain and range. We're going to do that for the blue graph shown. Don't mind the green and orange lines just yet. They'll become clear what they're for. So the domain is the set of all possible x values, you'll recall. And the best way to sort of figure out the domain from the graph is to scan from left to right. So when you think of finding the domain, you are scanning from left to right horizontally to see what x values are permissible in the graph, whether it be a function or a relation. So now let's follow the path. We're going to scan left to right. We're going to take that vertical green line, and we are right now at the very beginning of the graph, or the very first, the minimum x value is here at -2. So, and it's allowed to be -2 because that's a point that's on the graph. And then let's trace as the green bar moves from left to right from the minimum x value. So the minimum x value is -2 to the maximum. And you see that it moves along all the way up to 4, x equals 4, and it's allowed to be x equals 4. So the domain, in the past, we might have written, okay, so we can say that -2 is less than or equal to x is less than or equal to 4. That's the way to describe that little green number line, graph along the x-axis. And now we will be using interval notation in this video. So we might write more formally that x is contained in the interval -2 to 4. Now, if you don't recognize interval notation, you should check out my video on interval notation and set builder notation. I'll link that in the description. Okay, so let's have a look at the range now. So the range, find the range, you scan all possible y values, but this time you scan from low to high. So you are scanning vertically from what is the lowest y value that you can see. And you can see here that right now y equals 2, this y equals 2 is the lowest y value. And as we allow that, as we scan upwards to the highest y value, we see we kind of trace out this path here from 2 to 5. So we could say +2 this time. So +2 is less than or equal to, be careful here, we want to make sure we write y, which is less than or equal to 5, right? 5 is the highest y value. And we also might write y is contained in the interval 2, 5. Moving forward, we will not even write x is contained. We'll just write the interval notation like this for the domain and range, and that will kind of imply that we're either talking about x or y. So let's practice. So at any point, don't forget to pause the video and try it yourself before I reveal the solution. So for the domain of the graph shown, you want to scan from left to right. So what is the minimum x value that appears on the graph? It seems like it's -4. And what's the maximum x value is 5. So I would, and then sometimes I just shade in the x-axis number line just to sort of see the domain clearly. So x varies from -4 up to 5 inclusive. Now for the range, we are scanning from low to high, and the lowest y value is -3, and the highest it goes up to is 4, and it hits every y value in between. So the range is from -3 to 4. Now, what is useful is to take the same graph and make a slight modification. So what's different here? The only thing that's different is we have an open circle here, which means that x is not actually allowed to be -4, but it can still be every value above -4 all the way up to 5. So how do we indicate that with interval notation? We put a parentheses at -4, but we keep the closed bracket at 5. And how about the range? So the range, let's see, we're still here. Y is allowed to be -3, and that's the minimum, and the max is 4. And you might say, well, can it, let's see, it feels like y equals 1 is a problem because of this open circle. Sorry, now I just made it look closed. Let me just get rid of that. So it looks like y equals 1 might be a problem, but if you notice, if you just scan across from 1, you'll see that y still achieves the value 1 in several other places. So there is no break or gap in the range, and we would say, once again, it's still from -3 to 4. All those y values are represented on the graph. All right, so let's modify it even more. So we can see here that we have open circle at -4. Now here we have a little problem because notice that x equals 2. There is no point on the graph corresponding to x equals 2 because there's a hole there. But we can resume on the other side up until 5. So we have to write this a little more creatively. So we're allowed to go from -4 to 2. But we need to put a parentheses at 2 to show that it's not included, and then resume again on the other side, 2 to 5, close brackets. And finally, the range. What about the range? So here we still start at -3. We can achieve every value, so we go -3 all the way up, but now we can't go to 4, so we'll have a closed bracket on -3, and 4 we would put a parentheses to indicate 4 is not included. So let's look at some more modifications. Now in this case, notice that this graph here, hold on a minute, this graph is actually, it looks like it might stop at x equals -5.5, but it's not meant to. It's meant to continue on forever and ever. So what I need to add to this graph, which I didn't have before, which is a little arrow showing that it continues in that manner. So what does that mean about the domain? Well, if the arrow continues in that direction, then every x value, even that's off the screen there, so like -100, -1,000, eventually the graph will, have a point on it whose x coordinate corresponds to that. In fact, because if the arrow keeps going and going, x can range from anywhere from -infinity. We put a parentheses around -infinity because it can't quite achieve the unknown. So -infinity all the way up to 5. So the domain looks like this. And how would the range look? So again, because the arrow is continuing down, you can follow along. It's a little easier to see that the y coordinate can just keep sinking and sinking, so that we then say for the range as well, y can go from anywhere from -infinity up until, yes, there is a maximum y value at 4 still. All right, let's change it up a little more. So now we have an arrow here, which we put that back in. We also pretend there's an arrow right here. So if you look at the graph now is continuing down in this direction, and also in this direction forever. So that means the domain now, again, because it continues forever, it can go from -infinity, and now the maximum x value is no longer 5 or 6 or 7. I mean, it keeps going and going. So we would say that the domain goes from -infinity to infinity. And what about the range? Well, once again, because of the arrows, the y values can go as low as you'd like, so -infinity up to, but there's still a sort of cap on the y values at 4. Okay, so let's take another. Now in this one, I've taken out a chunk of the graph. As you can see, I've removed this portion of the graph, and we'll see what effect that has. So put those, oops, sorry, let me get the right color. Let's put those arrows in. Those arrows still remain. And the domain, again, x can be anywhere from -infinity, but it looks like we have a little break here. It can go to -1, and now it doesn't resume. X can't be anything between -1 and 2, right? There's no point on the graph that has an x coordinate of 1. So we resume at 2 and then to infinity, and we use a u to indicate that those intervals are connected. Now, what about the range? The range, again, goes from negative infinity, but I might actually trace up the y-axis. So we might get suspicious because of that break in the graph, but if we see -2, oh, there's a point on the graph, actually there's 2 points that have a y value of -2. As I trace up, -1, yes, 0, check, there's y values of 0 on the graph, 1, 2, 3, even 3, right? Look at that point there that has a y value of 3. It looks like we still can go, y can still go up to and including 4. So let's change up the graphs a little, make them a little more interesting. So remember, since it sort of goes, this graph goes all the way to the end of the grid, just assume that there are arrows there. And what's going on here? It looks like the graph is getting closer, say in this direction, closer and closer to the y-axis, but it never actually touches the y-axis. So we say that the y-axis is an asymptote to this graph. And similarly, the graph gets closer and closer to the x-axis, but never quite touches it. So the x-axis is also an asymptote. So how does that influence the domain and range? I'm going to kind of show the domain and range on the graph as I did in some of the earlier examples. So what is the smallest value that x can be on the graph? Well, we said it doesn't actually, x can never be 0 because it never crosses or it never touches the y-axis, the graph. But x can be anything above 0 and all the way up to, well, since the arrow continues, to infinity. So the domain, x varies from 0 to infinity, but we need parentheses on either side because 0 can't be included. And the range looks very similar. So the lowest y value, well, it has to be just above 0, right, because of the graph never touching the x-axis. And y can continue on up. So the same domain and range, nice and symmetric. All right, what have we got here? We've just sort of reflected that graph in the other quadrant. I'm not going to draw in all the arrows, it will take forever. So just assume they are there. And then let's think about the domain. So is there a minimum x value? Well, it looks like because the graph continues all the way to the left, x can be anywhere from -infinity, but it can't be 0. Right? There's no point on the graph that has an x-coordinate of 0, and then it can pick up on the other side to infinity. So we write -infinity to 0, not included, union, 0 to infinity. And what about the range? Well, is there a minimum y value? Not really, because it continues all the way to -infinity, but there's a break at 0, and then y can resume again up to positive infinity. So it's the exact same notation. All right, so what are we going to do next? We are going to add in this point here, let's see, which is, I just put an extra dot in there at 0, 0. And what that effectively does is it kind of gets rid of that 0 exclusion. So the domain now x is allowed to be anything from -infinity to infinity, because 0 is allowed now, and a ditto for the range, -infinity to infinity. So for our last practice problem, we're going to change things up a bit, and we're going to sketch a graph with the given domain and range. So let's kind of set our parameters. So this is the minimum x can be, so it can't go below -4. So I'm going to put a vertical line at -4, and I'm going to cross this area out because the graph cannot deviate into this area. And what about the maximum value? Well, it can't really achieve a max of 5, right? It could be 4.999 or very close. So I'm going to actually put a dotted line there and know that my graph can't have a point on that line or beyond. And all right, so now let's do the range. So the range minimum y value is -6. Solid line, because it could be -6. I'm going to cross out this area, and it can go anywhere to infinity. So if we draw this graph, let's see, where to start? That's the question, right? Well, -4, -6 is allowed. So to make sure I cover those values, I could just put a point like this here. And then I'm allowed to sort of go, anywhere from there up. So I could go up to here. Maybe I could come back down. maybe I could touch -6 again, but oh no, I have to actually get to infinity. So, but where? Where should I go to infinity? Well, the thing is that I can't actually achieve 5 in terms of my x value, so maybe I could do this and make the graph look like it's heading up to infinity. I would have an asymptote at x equals 5, and that graph would work. I could have also, let's see, what else could one do? So maybe, I'm going to keep that point there because I like that. Maybe I could have achieved going to infinity. Maybe I could have done this, right? So make the y-axis an asymptote, but then I want to be careful because x can be 0. So maybe I could put a point here, and then, I don't know, just a straight line like this, but with an open circle at x equals 5. So that would work as well. As you can see, there's lots of variations that could satisfy that domain and range, but this is just a couple of examples. Congrats, you made it to the end of my video. Hoping that means you found it helpful, and if so, please do like and subscribe, and check out more of my videos on my channel, Ready to Derive.